All right, so example 3, we're approximating the values. We want to find the value of the arcsecant of negative 3/2. How am I going to approximate values? That means they're not exact. So what do I do to find values that are close but not exact a lot of times? Well, it has the graph there in case you need it. But how about the calculator? So let's talk about how we would put this in our calculator. Well, let's start out like what we did in the other ones where we're doing it by hand. So we said that arcsecant, remember, it's the same as the inverse secant, right? And so if I take the inverse, I would have secant of theta equals negative 3/2. And then I can do the reciprocal. So cosine of theta equals negative 2/3. And before we were able to look at our unit circle and we were able to find where we were at. But to put this in our calculator, we're going to have to change this now back to the inverse. But notice on your calculator, you don't have an inverse secant button, okay? So that's why we had to take it to cosine. And then we're going to take the inverse, so we're going to switch those. So the inverse cosine of negative 2/3 will equal theta. So you type this in your calculator, and what did you get?
4.0.
All right, so good. You said 2.301. It's in radians, right?
Do one of these, they never die.
Really?
Yeah. They never die.
Now, to make sure that we did this right, though, let's go ahead and let's try it in degrees. How would we do that in degrees? And what do we get for degrees?
131.8.
So I got 131.81 degrees, approximately. Now, let's see. Does that make sense? We're looking at the inverse secant. What quadrants are we looking at? Quadrant 1 and 2, right? Because it's the reciprocal of cosine. Is 131 degrees in quadrant 1 or 2? Yes, so we know that our answer's good. All right, so let's do the same thing with example 4. All right, so let's see. Let's take the inverse first. So let's take cotangent of theta equals 1/2. And then the reciprocal. And then we could take the inverse of that. Now, let me show you something real quick, too, before you get busy in your calculator. You could go directly from this to the other, okay? You could say the reciprocal of cotangent, the inverse cotangent would be tangent, or the inverse tangent, excuse me. And the reciprocal of 1/2 is 2, all right? Because it didn't have the equals theta in it, it's just kind of implied. I guess the theta is not going to switch. But if you notice, that's the same exact thing we have there, okay? So you don't have to go through all the other steps. I like the other steps because if we're doing this by hand, then we're used to those steps. We've trained our brain to do it. But either way. All right, so what is the inverse tangent of 2 equal to? So 1.107, that's in radians. And so let's try it in degrees just to see if it's in a quadrant it's supposed to be in. Okay. What quadrant is that? Quadrant 1. Is cotangent allowed to be in quadrant 1? Excuse me, is inverse cotangent allowed to be in quadrant 1? Yes. So we're good there.